Water has some unique properties that we're going to study in this chapter. Water molecules have an especially strong attraction with each other. This interaction between water molecules is called hydrogen bonding. It's an especially strong intermolecular force. There are very strong dipole-dipole interactions between the water molecules, and this only happens when you have hydrogen covalently bonded to fluorine, oxygen, or nitrogen. Examples would be water, hydrogen fluoride, and ammonia. Water's bent shape and hydrogen bonding give water molecules many special properties. The water molecules are very strongly attracted to each other, and this gives water a high surface tension, high boiling point, and a very low vapor pressure. If you've ever waited for water to boil, you know that there must be very strong intermolecular forces. It takes a lot of heat energy and a lot of time to turn the liquid water into the gaseous state. The water molecules within the liquid are all attracted to each other, as you can see in this little pink attractive force diagram. But the molecules on the surface of the liquid are attracted only downward. They're not attracted up towards the air. So there's this net downward pull on the surface that sort of makes a skin on the surface of the liquid. The surface tension of water allows things that are much heavier than water to float on the surface. Beating is another effect of the intermolecular forces of water, the hydrogen bonding. If a polar substance is placed on a nonpolar surface, there are going to be cohesive forces, forces between the like molecules, but there won't be any adhesive forces, forces between unlike molecules. So you're going to get beating on the surface as the cohesive forces pull together. In this slow motion picture of water dropping, you can see that as the drop spreads away, it is still pulling back on itself with those strong cohesive forces. A meniscus in a graduated cylinder or beaker is also caused by these cohesive and adhesive forces. As the water molecules are attracted to each other, they are also attracted to the surface of the glass. So the cohesive and adhesive forces pull the water up the side of the beaker or graduated cylinder. When water molecules freeze to the solid state, they keep their bond angle, and this forms an open crystal lattice structure. Water always freezes with the same bond angle, creating a crystal lattice structure with a six-sided arrangement of the water molecules. In order to be soluble in water, molecules must be polar molecules. The polar molecules are attracted to the polar water and therefore dissolve in each other. You can see in this picture the nonpolar oil sits on the surface of the polar water. There's no attraction between the two liquids. Soap is a long molecule with a large hydrophobic or nonpolar end that is water-hating. The soap molecule also contains a hydrophilic or polar end that is attracted to water. This is the water-loving end of the soap molecule. The hydrophobic end, or the nonpolar end, will dissolve in grease. The hydrophilic end of the soap molecule, or the polar end, will dissolve in water. The structure of the soap molecule allows for oil and grease to be brought together with water and washed off. It also allows for the formation of soap bubbles.